Hi, Jakub Kaluzny here, and today's instant threat modeling 5-minute video series on security features the first guest, Damien, an expert in blockchain and smart contract security, who helped me preparing content for today's Hacking Blockchain episode. By the way, this won't be the only episode with Damien. We'll talk more about cryptocurrencies and smart contracts, but today let's focus on blockchains such as HyperLedger. Damien, what is this all about?
High-level overview is that we have a user and a blockchain. User interfaces allow to communicate with the blockchain indirectly. These are the web applications consuming external API provided by some nodes. Now, inside the blockchain, the ecosystem consists of peers and the orderer. Peers belong to the organizations, and those have the certificate authorities. Organizations maintain a standard infrastructure of servers, databases, monitoring and orchestration software. Ledgers keep the history of all transactions and cache of the current state. You can deploy smart contracts, which is code that represents business logic. Configurable channels allow to separate the logic of multiple deployments and applications. In the end, peers want to put transactions on the blockchain, and orderer orders them, verifies and propagates through the chain.
Cool. Who is the threat actor? For sure, an anonymous external attacker. Blockchain organizations, those that want to manipulate or dominate the other ones, and an owner of certain private keys in this ecosystem. What can go wrong? Well, first of all, we have the interface API private key compromise. Then web application attack vectors for all interfaces. Same for the API here, common API attack vectors. Private key compromise of the blockchain certificate authority. This may actually be possible with CI/CD attacks I mentioned in one of the previous episodes. Think about default admin password for your repositories or build server. Standard technical infrastructure attacks. Think about default configuration of your Apache Kafka or caching issues. Nodes can be single point of failure. Denial of service goes here. Channels have configurable policies. Bypassing those may allow unauthorized access to the channels. These policies and smart contracts may make one organization too powerful in the ecosystem. When talking about smart contracts, vulnerabilities in those may lead to remote code executions here in the peers infrastructure. And smart contracts, as any other code, may have access control issues. Bypassing access control may lead to business logic flaws. Instant mitigations. For the private key compromise of both external interfaces and certificate authority, encryption at rest, and protection of the temporary decrypted cache storage. Web application based threat model for the APIs and the infrastructure as well. Each organization should maintain their node, ideally multiple nodes and on-prem or using multiple cloud providers. Channel policy configuration review and per organization access analysis. Design review to avoid and detect too powerful organizations. The configuration should be approved by the majority of the consortium. Granular smart contracts are easier to review for potential access control issues. Previous issues were focused on the design, while this is quality of code. We often find vulnerabilities when doing code review of smart contracts. Damien published Smart Contract Security Verification Standard, or SCSVS, which is a list of checks security requirements for smart contracts. And there is also DASP Top 10, which is Decentralized Application Security Projects by NCC Group. This was instant threat modeling of blockchain security. Feel free to contact us regarding your blockchain application. All previous episodes at securing.biz/itm. Cheers!